Hello, everybody. My name is Carlos Antonio Centurión. Thank you very much for your presence and your interest in this topic that we present along with Gregorio Hernandez and Eric Sanchez from TDM and Tensar Engineering Department, respectively. On this occasion, we are going to briefly tell you about the use of geosynthetic in the new airport in Mexico City, with focus in the use of geogrid and geotextile for the stabilization of subsoils. The new Mexico City airport was for several years, as far as geosynthetics are concerned, the most important project in the region. It concentrated the main Mexican construction companies as well as the most important geosynthetic suppliers of the world. Until its cancellation in 2018, more than 9.5 million square yards of multi-axial geogrids, approximately 13 million square yards of geotextile, and more than 230 million feet of grid drains had already been installed, which shows by itself the scale of this important project. In addition, not only those geosynthetics were used, biaxial geogrids were also installed in some areas, and certain main roads and access roads were reinforced with geocells. However, the large amount of the geosynthetic use were rigid polypropylene geogrids, and it is on the application that this presentation will focus. The name had been being built in the federal zone of the former Lake of Texcoco, northwest region of the Valley of Mexico, within the municipalities of Texcoco and Atenco. The almost 12,300 acres where the name will take shape were selected based on feasibility and technical studies carried out by ARUP, Meter Corporation, International Civil Aviation Organization, International Air Transportation Association, and the Institute of Engineering of UNAM. The architectural design of the name was created by architects Fernando Romero, founder of the architecture firm Free, and Norman Foster, winner of the Pritzker Prize, recognition equivalent to the Nobel Prize in Architecture. The design of the new airport, specifically the X that can be seen in the terminal area, was inspired by the national symbol of the eagle on a cactus nopal, devouring a snake, as we can see in the photo of the right. The geotechnical challenge was represented by the foundation soil. The soil on which the new airport was built is very soft, product of a city built on a place that was a lake in the past, constituted by clays, compressible, and with a moisture content over 400% soils. The objective in this case is to adequately control to the consolidation deformations that may experience any structure built on them. And not only that, in addition to the effects of high compressibility, the seismic effect must be added. As can be seen in the photograph, the problems arose from the construction of accesses from cleaning and construction. Well, what was done? To show the works at the airport, we are going to divide the presentation in two large groups: the works within the airport and the works around the airport. The field works was the leveling and cleaning of the areas, and it was here that stable work platforms were created for the entry of construction teams in an area of more than 2,800 acres. These work platforms, these white work areas, were made up of a separation non-woven geotextiles, a rigid multi-axial polypropylene geogrids, and 20-inch of tessontle, which is a red volcanic rock, light, widely used in construction in Mexico. After the works of regulation and stabilization of surfaces, the access roads were built. They were designed to facilitate the transfer of materials and aggregates. There were 13 major axes divided into primary axes from south and north, and secondary axes from the east or to west. totaling 30 miles of access road. In this case, not only multi-axial geogrids and geotextile were used, but geocells were also used in some sections to reinforce the pavement structure. Unfortunately, I was not personally involved in those specific jobs, so I do not have more details. Due to the great magnitude of the project, it was necessary to speed up the process of transporting aggregates and materials. And that is why a section of railroads was built to transport aggregates from an area called Otumba to Texcoco. More than 1.5 million square feet of geotextile were used. And in the airport and strand area, the ballast was reinforced with a TX 190 type multi-axial geogrid due to the fact that it's present an opening according to the size of the aggregate. And so we can take a trip through the ground transportation center, which was built by Saussure Company. Over 195,000 square feet of multi-axial geogrid were installed to create stable works platforms to allow for the construction of parking lots and metro buses. Now, we have the takeoff runways, specifically the runways 2, 3, and 6, that totaled 3.1 miles in length and 200 feet in width. In these areas, consolidation treatments were also used with thick wheat grains nailed 85 feet deep and preload embankments, which consisted of 40-inch of the Sontle and 2 layers of 40-inch also of crushed stone. Key companies such as Coconut, Sedena, and Cargill Folly Planet developed and executed this part. The terminal building will have 8 million square feet of multi-axial geogrids that were used to generate the access of the drilling equipment and allow the nailing of the pipe in subsequent construction of the large concrete slabs. Grupo Indy oversaw the driving of piles and concrete slabs construction on behalf of ICA, who actually developed the aggregate thickness reduction project. Starting from an in situ CBR of 0.8%, the use of multi-axial geogrids allowed reducing the original aggregate thickness from 35-inch to only 15-inch. So we then went through the control tower, where also the surrounding areas were stabilized with multi-axial geogrids and non-woven geotextile, totaling 248,000 square feet. In the part of attached roads, we have several roads that were built to access the airport from different parts of Mexico City. We have the case of Lecheria Texcoco, Pirámides Texcoco, or the same exterior circuit Mexicans, among others. Specifically, in the case of Pirámides Texcoco, EPS blocks covered by each DPA geomembrane were used in order to reduce the weight of the embankments and thus reduce deformations. We can see in the photos the polystyrene blocks lined with each DPA geomembrane to avoid that humidity coming from water table as well as full leaking can actually damage to the blocks. A very interesting project that until its cancellation is 2018, as we said before, more than 9.5 million square feet of multi-axial geogrid, approximately 13 million square yards of geotextile, and more than 230 million feet of weak drains had already been installed in the subway stabilization of internal access roads, foundation improvement of the large terminal slabs, departure and arrivals platforms, control tower, and runways 2, 3, and 6, making it perhaps the largest work in the use of geosynthetics worldwide at the time. For this reason, despite the cancellation of the project and the serious accusation of corruption that surrounded it, This is still an extraordinary work of engineering that leave valuable lesson and different application of geosynthetics that with its success in this difficult and important project opened the way to massive application in different infrastructure projects in Mexico and the region. Thank you very much.